Okay, so we're getting into log compaction, and that's quite an advanced setting and thing to understand. But log compaction basically ensures that your log, and by log we mean the partition, contains at least the last known value for a specific key within the partition. Okay, so this is very useful if we just require a snapshot of instead of the full history. Like an example of this is a data table in a database. We never know the row history, we just know the last value for each row. So the idea is that we want to keep in Kafka only the latest update for our key in our log. So that means that we basically want to keep the most recent and most valuable information. So you may say, why would I ever want this and how does that work? Okay, so let's go through an example. So we'll take a topic and our topic is employee salary. And we want to keep the most recent salary for our employee. We actually don't really care about knowing about old salaries. So here is how the writes will happen in our partition. We'll have key equals John and salary equals, say, 80,000. Then key equals Mark and salary, say, is 90,000. Key equals Lisa and the salary is 95,000. This is our segment 0, our first segment. Now, after a while, some things happened and we're at segment 2 already. And it turns out that Lisa has a salary of 110,000, while John has a salary of 100,000. Okay, so as we can see, the color coding shows that the key Lisa and the key John have been updated. Okay, so what happens when log compaction happens is that the old John and the old Lisa keys will be deleted because there's a newer key available. And as a result of this, we'll get a new segment. As you can see, the offsets do not change, it's just that some data gets removed. So what are the guarantees for log compaction? Well, any consumer that is reading from the tail of the log, and by tail I mean the most current data, so this is data as it comes in, will still see all the messages sent to the topic. So from a consumer perspective that is reading from the topic, it will still see everything being sent just like normal. The ordering of messages is kept, but log compaction only removes some messages and does not reorder them, okay? So as we've seen, the offsets are kept, just some messages are removed. The offset, as I said, is immutable, okay? So that doesn't change anything, it never changes. And if an offset is missing, it's just skipped. And if you delete a record, it can still be seen by a consumer for a period of delete retention millisecond. By default, it's 24 hours. So it gives some time to your consumers to catch up in case some data has been deleted. Okay, so some myth busting on log compaction. Number one, it does not prevent you from pushing duplicates data to Kafka because the log compaction only happens after a segment is committed. That means that your consumers will still see all the data that is sent to the topic as soon as it arrives because it reads from the tail. So it does not prevent you to pushing duplicates. It is not a deduplication way in anything, okay? As we've seen, if you want to prevent at least network duplicates, you should use an idempotent producer. It either doesn't prevent you from reading duplicate data from Kafka, okay? When your consumer restarts or for any reason, your consumers may see duplicate data. So log compaction does not help with those. Log compaction can fail from time to time. So it's an optimization and the compaction thread might crash. So you need to ensure that you have enough memory, so enough RAM, okay, on it, and that it actually gets triggered. And for this, you can look at the log. If Kafka logs doesn't show that the compaction is happening, maybe it's broken and you need to restart Kafka for it to happen. This is actually a bug and the Kafka team is aware of it and it will be fixed in the future. But as of Kafka 2.0, I still believe this happens and log compaction can be broken sometimes. Overall, log compaction is something that happens in the background and we can't really trigger it using an API call for now. Okay, so in the next lecture, I'll show you how we can set a few settings to trigger it often. Obviously, they're not recommended. You just need to let it happen naturally. So log compaction, what does it realistically do? It takes your segments, and we have a few segments, and it will clean them up. So it will look at all the keys and all the committed segments, and basically will remove the keys needed and make a new segment out of it, which gather all the offsets. And so that's basically the idea, while the active segments still remains active and untouched, okay? So log compaction, as you can see, basically compacts, hence the name, compacts different segments into smaller segments and deletes keys as we've seen before. So it's configured by log cleanup policy equals compact. And we have segment millisecond that can trigger it more often. So this is the maximum of time to wait before closing an active segment, which is 7 days by default. Segment bytes, which is 1 gigabyte, which is the max size of a segment. Min compaction lag millisecond, by default is 0, is how long to wait before a message can be compacted. Delete retention millisecond, which is by default 24 hours. So this is how long a consumer can still see deleted data before it actually is fully deleted. By default, it's 24 hours, and you want to usually keep this as 24 hours. And finally, min cleanable dirty ratio. If we set something higher, we'll have less compaction, okay, and more efficient cleaning. And if we set it to a lower setting, and that's what we'll do in our hands-on just for proving the point, we'll have the opposite behavior. That means that we'll have less efficient cleaning, but a lot more cleanings happening, okay? Overall, min cleanable dirty ratio 0.5 is a good default, but we'll just tweak it so we can trigger log compaction easily in the next lecture. So hope you liked it, and I will see you in the next lecture.